All right, guys, are there any questions over the homework assignments before we get started?
Yes.
Okay.
Hold on, let me find the workout.
522.
Yeah.
Which problem?
Number 15.
So for 15, we're looking at the fourth root of 6 times the fourth root of 8. Now, we can try this on the calculator and see what it tells us. So we can say the fourth root of 6 times the fourth root of 8, and it gives us a decimal answer. So we can't just do this in the calculator to get an answer. Now, we can look at the prime factorization of both numbers. So 8 is 2 times 4. 4 is 2 times 2. So 8 is 2 to the third. So we can't take the fourth root of it because we only have 3 2's. For us to simplify it, we need 4. Now 6, this is prime factorization, well, is 2 times 3. That's as simplified as we can get it. Now if we multiply both of these together, we have 2 times 2 to the third, which is 2 to the fourth. And then we have times 3. Now with doing that multiplication, 2 to the fourth, or sorry, the fourth root of 2 to the fourth is just 2. So whenever it won't simplify inside the radical, we do our prime factorization. We break it down into the product of primes. So for 8, it's 2 to the third. 6 is just 2 times 3. And then we can simplify it from there. Thank you. Any other questions on the homework? Okay. Now what we're doing today is a continuation of what we did Thursday. Solving. Yep. 5.41. No. 541. So, all right, guys. So, what we're doing today is a continuation from Thursday with solving. Now, there were several steps that we had with solving the first. And again, it might be phrased a little bit differently, but it's still the same concept. Is there one radical? Is there one radical? If yes, get it by itself. Is there one radical? If yes, get it by itself. If no, even them out. Our second step was to put both sides to the nth power. Step 3. If there are still radicals left, repeat steps 1 and 2. And the last step is to solve. Now, for the most part, we won't deal with too many, if any, that are going to require step number 3. But if we do still have radicals left, we will end up having to repeat steps 1 and 2. And it's not anything more difficult or anything challenging. We just have to repeat the steps and do them again. So when we look at this first problem here, x is equal to the square root of x plus 6. So is there more than one radical here? No. So we just need to get it by itself. Is the radical by itself? Is there anything being multiplied in front of the radical? Is there anything being added to the radical? So is it by itself? No. Okay. So the radical is by itself. We really not too concerned about the fact there's x plus 6 inside the radical because there's nothing else outside. So we move on to step number 2. We put both sides to the nth power. Now what power are we going to use for this here? Second. And the reason we use this is just like on Thursday. If we look at the left-hand side, the square root and square will cancel out, leaving us with just x plus 6. Now on the left-hand side, we have x squared, which is just x squared. So we finished step number 2. Step number 3, are there any radicals left? No. So we don't have to do anything with step 3. We can go on to step 4 and solve. Now since we do have a quadratic, an x squared term, we need to get this equation equal to 0. So we need to move everything to the same side. So the first thing we can do is subtract x from both sides. Since x squared and x are not like terms, on the left-hand side we have x squared minus x. On the right-hand side, the x and x simplify to 0, giving us x squared minus x is equal to 6. But again, we need this equal to 0. So the next thing we can do is subtract 6, telling us that x squared minus 6 is 0. Now that we have it equal to 0, we can solve this here. So we can do this by graphing, factoring, quadratic formula, any of these methods here. Now because the number in front of x squared is 1, that tells us the likelihood that our solutions are going to be fractional, rational solutions, is we're not going to have 1/2. We're not going to have a fraction. So graphing would work. We can also factor. 2 sets of parentheses equals 0. And we can look at the signs first. Since our third term, our 6, is negative, our signs are opposite. One's going to be positive, one is going to be negative. Our factors of the first and third term are what we look at next. So the factors of x squared are x and x. So that's the only set of factors that we have for x squared. So we can go on and fill those in. Now the factors for 6 that we have are 1 and 6 or 2 and 3. Which one do we want? 2 and 3, which one's positive, which one's negative? 2 is positive, 3 would indeed be negative, for us to have a middle term of negative x. Lastly, in solving, is our zero product property. Zero product property states if we had one or more things multiplied together to equal 0, well, 2 or more things multiplied together equals 0, one of them must be 0. So we're saying that either x plus 2 is 0 or x minus 3 is 0. And if we solve x plus 2, we would subtract 2 from both sides, telling us x is equal to negative 2. For x minus 3, we would add 3 to both sides, telling us x is equal to 3. We have this here. Any questions on any of this so far? Now, before we move on to the next one, we do need to check and make sure that these work. Negative 2 and 3. So we can try negative 2 first. So if I plug it into the equation, we'd have negative 2 is equal to the square root of negative 2 plus 6. On the left-hand side, we would just have negative 2. On the right-hand side, we'd have the square root of negative 2 plus 6. Well, negative 2 plus 6 is 4. Square root of 4 is 2. Is 2 equal to negative 2? No. So that tells us that x is equal to negative 2 is an extraneous solution and does not work. We can do the same thing with 3. We can plug 3 in for x in both places. So on the left-hand side, we just have 3. That's the only thing on that side. The other side, we have the square root of 3 plus 6. Well, 3 plus 6 is, square root of 9 is. So x is equal to 3 is our solution. Now, most of these here with solving radical equations, if we have a variable outside the radical, like we started out at the beginning, there's a good chance, a high likelihood that we will have an extraneous solution. All the ones we did on Thursday did not have an extraneous solution, but none of them had a variable outside the radical. And the reason that we get these extraneous solutions is because our first step is squaring both sides. So this side here, where for negative 2 we do have this setup, when we square it, it turns it positive. And having this square the other side would tell us 4 is equal to 4. But in the original equation, we have nothing to offset this negative to start with, so we end up getting this extraneous solution, this solution that doesn't work. So the only one that works for this one here is x is equal to 3. Questions on this here? Let's look at the next one here. Let's look at this one here. X is equal to the square root of 20 minus x. Is there only one radical? So we need to get it by itself. Is the radical by itself? Okay. So that means we can move on to step 2, put both sides to the nth power. So what are we going to put both sides to? 2. Because here the square root and square would cancel, leaving us with 20 minus x. All right, guys. Now at this point here, we have a quadratic. We know we have a quadratic because of the x squared term. And since we have a quadratic, we need to get this equation equal to 0. So there's different things we can do first. So we could say we can add x to both sides. On the left-hand side, we'd have x squared plus x is equal to, these two cancel, leaving us with 20. Next step would be to subtract 20, telling us that x squared plus x minus 20 is equal to 0. Any questions on how we got to this point here? Now again, at this point, we can factor it, we can graph it, we can do any of these methods to solve. If we wanted to factor, or not factor, but graph it, we can use the graphing calculator and hit y equals and type the function in. So x squared plus x minus 20. And once we get it typed in and hit graph, we're looking to see where it crosses the x-axis. Because if it crosses at nice points, that's going to tell us exactly what the values are. And if we go second graph, look at the table, well, we can see one of the values that works is 4. Because we're looking for where y is 0. So 4, x equals 4, is one of the solutions. And with quadratics, they will cross at 2 locations. 0, negative 20 is not one of our solutions because we're looking to see what values of x make y be 0, not the other way around. So we can keep going up, and the other one is negative 5. So the two solutions that we have for this are when x is 4 and x is negative 5. Any questions on how we found these two here? Bless you. We good with how we found these two here? Now we can check these, plug them back into the original equation. 4, negative 5. Now we can check 4 first. So we can say 4 is equal to the square root of 20 minus 4. The left-hand side is just 4. Now the right-hand side, we could do it the same way we did on the last one, work it out step by step, or we can type it into the calculator, and exactly 20 minus 4 would be the square root of 16, which is indeed 4. So we get 4 is equal to 4. So x equals 4 does work. Now for negative 5, we can plug it in.
Will they ever both work?
Yes, I mean, there are going to be some cases where both do work, but here we end up getting one that works and one that doesn't. For the left-hand side, we have negative 5. On the right-hand side, we have second square root of 20 minus negative 5, which is 5. So these don't work. And again, the reason that we get this other case is because our first step is to square both sides. And when we square both sides, this negative 5, when squared, is positive 25. And when we square the right-hand side, we also get positive 25. But in the original problem, we have nothing to change that negative, to adjust for that. So that's where we get this extraneous solution.
20 minus negative 5 is like two solutions, except just the minus changed to a plus, right? Okay.
20 plus 5. Yes. Because we can, the negative, it's almost, we're saying the opposite of negative 5. So the opposite of negative 5 is positive 5. So we have plus. Any questions on any of these here so far? So, looking at this here, do we have one radical? Yes.
Yes.
Is it by itself? Okay, so we need to put both sides to the nth power. And in this case, the nth power would be 2. Again. And we do that, the square root and the square would cancel, leaving us with 4 minus 3x is equal to x squared. Now, since we do have an x squared term, we need to get this equation equal to 0. And since x squared is already on the right-hand side, I like keeping x squared positive. So the first thing we can do is add 3x to both sides, which will tell us 4 is equal to x squared plus 3x. Now, since the equation is still not equal to 0, we can move the 4 over by subtracting it. Minus 0 is equal to x squared plus 3x minus 4. Any questions on how we got to this quadratic?
Nope.
Do we want to solve this by factoring or graphing? We can do both. So if we solve this by factoring, so we'll have our 2 sets of parentheses, and we're going to have 3 spots in either one. Now, since the third term is negative, our signs are positive and negative. They're going to be opposite. The factors of x squared are x and x. Those are the only factors of x squared. Now, the factors of 4, we do have more than one. We have 1 and 4 or 2 and 2. Which one do we want to use?
1.
1 and 4, which one's positive, which one's negative? Yes, and negative 1. Since we have 2 things multiplied together equals 0, one of them must be. We have x plus 4 is equal to 0, and x minus 1 is 0. And at this point here, to solve, for the x plus 4, we would minus 4 from both sides. Minus x is equal to negative 4. So on the other side, we would add 1 to both sides, telling us x is equal to 1. Any questions on how we found these 2 solutions here? Now we can check these 2 solutions. We can start off with negative 4.
Can I use the rush?
Yes. So we have negative 4 on the right-hand side. We have 4 minus 3 times negative 4. And we can plug that into a calculator. Minus 3 times negative 4, which gives us positive 4. But in the end, we're saying 4 is equal to negative 4, which is not true. So negative 4 is not one of our solutions. We can do the same thing with 1. 4 minus 3 times 1 is equal to 1. Well, the right-hand side is just going to be 1. The left-hand side, we can check and say square root of 4 minus 3 times 1, which is 1. 1 is equal to 1, it works. So the one solution that does work, or the solutions that do work, is just x equals 1. Questions on any of this here? Any questions over anything we've done so far? Are you ready for the next one? Solve 13 plus the square root of 5n is equal to 3. So again, when we look at this here, is there one radical? Is it by itself? No. So what do we need to do to this here to get the radical by itself?
Add 3 over.
So what is with the radical? The 13, yes? So we would indeed subtract 13 from both sides, because here 13 minus 13 is 0, which will leave us with the square root of 5n is equal to 3 minus 13 is negative 10. Is the radical by itself? Yes, there's nothing being multiplied in front of the radical. There's nothing added or subtracted to it. So it is by itself, which means we can put both sides to the second power. Well, on the left-hand side, this radical and square will cancel, telling us 5n is equal to negative 10 squared is what? 100. If negative 10 times negative 10, the negative times a negative is a positive, and 10 times 10 is 100. And then lastly, what can we do? Divide both sides by 5, telling us n is equal to 20. And we can go on and check it just to make sure. 13 plus the square root of 5 times 20 is equal to 3. Now again, at this point, we could type the entire left side of the equation in. 13 plus square root of 5 times 20. Hit enter, we get 23, yes? So 23 is equal to 3. Is that true? No. And if we did this step by step, because if we actually worked this part out, because the square root of 5 times 20, well, that's just the square root of 100. Well, the square root of 100 is 10. We'll carry it away. So we're saying that 23 is equal to 3, which isn't true. So n equals 20 doesn't work. Do we have any other solutions to check? So we're saying this here is a no solution. Because anytime we go through and check all of the solutions and it works out none of them work, we have a no solution. Now before we move on to the next one, I want to look back at this one here. I want to back up to this part here. Square root of 5n is equal to negative 10, yes? Well, the reverse of this, really what we're trying to see, the number inside, is we're saying what times itself gives us this here, yes? Is there any way that I can have a negative come out of a radical? So we're saying here, so the square root of 100 is positive 10, yes? If I said the square root of negative 100, well, that is 9. It just doesn't work. We cannot take a square root, an even root, and get a negative. It just doesn't work. So if we get the radical by itself and it's equal to a negative number, it doesn't work. This is a no solution. Even if we don't notice that, that's fine. But we can go through solve it, and if we check back, we plug the answer back in, it's not going to work.
So we just get to there and they're like, oh, no solution.
Mm-hmm. If we don't notice it, we can continue solving and then check it, and it'll come back that it doesn't work. So if we look at this one here, step one, we do have one radical. We need to get it by itself. Yes? So we would subtract 10 from both sides, telling us that the square root of 3m is equal to -9. No solution. As we're saying, whatever number inside there, when multiplied by itself, is negative, and it just doesn't work. If it was an odd number of times, it would work, but not with an even number. So this here is not true. This is no solution. Whenever we have the square root of something equals a negative number, it doesn't work. But again, we've got to get it by itself first. We've got to get it by itself first. Because if we just said -3m equals -9, this does work because we would divide both sides by -1, making it be the square root of 3m is equal to 9. This is part of the reason, or the main reason, especially our first step, is to get the radical by itself. Because it helps us be able to see if it is indeed a no solution or not. But again, it'll still tell you the same thing. Even if we don't notice this, we still get to the same spot. Any questions on any of this here? Let's look at this next one. So we look at this one here. Again, this is the first one where we had a variable and a number, more than one thing outside the radical. And our first main step does not change. Is there one radical?
Yeah.
Is the radical by itself?
Yeah.
So that means we can go on to step 2 and put both sides to the nth power. In this case, it would be to the second power. Now on the left, or not left hand, but the right hand side, the radical and square will cancel because the only thing on that side is the square root of 7p plus 15, which leaves us with 7p plus 15. The right, or the left-hand side is now p plus 1 squared, which is really telling us that we have the quantity p plus 1 times p plus 1. We can't say that it's p squared plus 1 squared. It's that term times itself. Which means we actually have to use our distributive property and multiply this through. P times p is going to be p squared. P times 1 is going to be plus p. 1 times p is going to be plus p. And lastly, 1 times 1 is going to be plus 1. So on either side, if we have any terms added or subtracted, we have to actually multiply it out. In all the cases up to this point, we've only had one term on either side, so we can just square that individual term and go from there. Now at this point here, we can combine like terms. P plus p would give us 2p. P repeatedly. It is quite funny indeed. Now at this point here, we will need to get the p's by themselves. So we can, or get everything equal to 0. So we can subtract 7p from both sides, which will tell us that p squared minus 5p plus 1 is equal to 15. Now again, it's not equal to 0, so we can subtract 15 from both sides. So it's that p squared minus 5p minus 14 is equal to 0. Yes. So we can factor this here. Since the 14 is negative, our signs are opposite. One's going to be positive, one's going to be negative. Now the factors of p squared are pp. Factors of 14. We have 1 and 14. 2 and 7. Which one's positive, which one's negative? Negative. Since we have two things multiplied together to equal 0, one of them must be 0. So for our p plus 2, we can subtract 2 from both sides, telling us that p is negative 2. For the other side, we can add 7 to both sides, telling us p is equal to 7. Now to finish this off again, we're going to check our solutions to see if one or both is an extraneous solution. So we can start off with negative 2. So on the left-hand side, we have negative 2 plus 1, and negative 2 plus 1 is negative 1. There's a good chance this is not going to be the correct solution, but we can still check the other side. And we can plug it into a calculator, say square root of 7 times negative 2 plus 15 is 1. 1 is not equal to negative 1, so p equals negative 2 does not work. We can do the same thing with 7 when p is 7. On the left-hand side, we have 7 plus 1, and 7 plus 1 is 8. On the right-hand side, we have the square root of 7 times 7 plus 15, which is 8. So when p is 7, when we check it, we do get 8 equals 8. So the solution for this here is that p is equal to 7. Any questions on any of this here? And looking between the two of these here, is this here, what we did today, any harder than what we did last week? It's not really any harder. We just have solutions that we have to check, problems that we have to work through and figure out. Any questions on any of this here? Do we feel pretty comfortable with this here? Yeah. Now, what we will get to, so on the next day that we're in here, so we'll see, we will cover one like this here. We just won't do it now. Now your homework for today is this here. So on page 269, problems 45, 46, and 49 through 57 odd. 45 and 46, we didn't specifically talk about them. It's just determine whether, if any, it is an extraneous solution. So 45 and 46, you're just plugging those numbers in for x and determining if it is an extraneous solution. Extraneous solutions are the ones that work or the ones that don't work. Extraneous are the ones that do not work, because if they're extraneous solution, they do not work. So it's not asking you which ones work, but it's asking you which ones do not work. So when we list those out, you're listing the ones out of those 2, 1, 2, both or neither, which ones do not work in that equation. 49, 51, 53, 55, and 57, you're solving those there and finding the value of the variable that does work.